Alright, in today's lesson what we're going to do is we're going to look at factoring the difference of squares. So if we considered x squared minus 9, it looks like it's not factorable, but indeed it is. Remember, that means that there's b value 0. 0 times x is 0, so we don't show it. So factoring, we look at we look for two integers that add to 0 and multiply to negative c. That's our goal. All right. So in this case, we have those. So I'll show you what I mean by that. So we're going to rewrite this as equal to, make it red. So it's going to be equal to, we just take the x, we put the x in brackets, and that could be squared, minus, and then the brackets 3 squared. All right. So take the square root of x squared, which is x. Take the square root of 9, which is 3. It has to be a subtract. The addition is not going to work. And then this actually equals, so we do this. This is going to be equal to, and it's going to be x minus 3, x plus 3. And that's what it factors to. Pretty straightforward. You can do if you don't see that and you're like, I don't get that, sir, well, here's what we'll do verify, we'll do it in the reverse order, and then you'll definitely see it. So we take this, remember the distributive property would be x multiplied by x plus 3 minus 3 multiplied by x plus 3, right? So first times the binomials, and then we'll see what happens here when we do this. So let's multiply this out. So x times x is obviously x squared. So we have x times x, which gives us x squared. And we have x times 3, which gives us 3x. Then we have negative 3 times x, which gives us negative 3x. We have negative 3 times 3, which gives us minus 9. So when we simplify this, we end up with, see the 3x minus 3x, that comes 0x plus 0x, right? Because a negative 3 plus positive 3 is 0. So use what you see up here, and then we don't need to show the 0x, obviously, and that becomes minus x, or minus 9, sorry, it's gone. All right, so we can say that we have the difference of squares. All right, a minus b is going to be a minus b, a minus b. And then this next one we have is going to be a plus b. It's as simple as that. Okay? And that's all there is to it. Let's look at example 3. So this is going to be equal to x, equals bracket x minus 4 x plus 4, right? So take the square root of x squared, get x, take the square root of 16, get 4, and 1's plus, 1's minus. Simple as that. Okay? Let's look at the next one. So the square root of 25t squared is 5t. Square root of 81 is 9. So 1's 5t plus 9 and 1's 5t minus 9. The order does not matter. That's it. Simple as that. Now this one here, we have they're showing the square root sorry, the showing 49 first, the constant first, and the squared second. It doesn't make a difference. It's still done the same way. Alright, so it's going to be equal to bracket 7 square root of 49, and the square root of 9y squared is going to be 3y, and then plus, so then it's going to be 7 plus 3y. That's it. Simple as that. Always remember to factor the common factor first. So one of the earliest things we did factoring, see if you can factor. So if you look at this, you can't take the square root of 3x squared because it's going to give you a decimal. You can't take square root of 27, it's going to be 5 decimal something. However, if you look close, little more closely, you can factor to 3 out of both, and you end up with x squared minus 9. Oh, x squared minus 9. Okay? And then you'll notice that we have the difference of squares that we had in the original question there, and that's going to be equal to 3 is fine, and then the x squared, square root of x squared is x, square root of 9 is 3, so we end up with x minus 3, x plus 3. So you got to get a GCF out first when possible. Here we have 8ab squared 50, so like I said, at first glance it looks like it's not, but then you got to get a GCF of 8 and 50. Does 8 and 50 have a GCF? Yes, it does. You could factor out a 2 from each. So we'd have 2. They both have an A, so an A can come out. And that's it. So that's going to leave you with 4b squared minus 25c squared, because we didn't take any variables out because there was no common, just the a in both. So it looked like we had a mess at first, but then you look at this, and I'm going to do this one in a few extra steps here. So the 4b squared, if you take the square root of that, you would get 2b, and if you take the square root of 25c squared d squared, you would end up with 5cd. So indeed it does factor. So we get 2b, which is the square root of 4b squared, and 5, which is the square root of 25. Square root of c squared is c, and the square root of d squared is d. And there you go. And then don't forget to write the exact same one, only with a plus in between. Remember, this has to be negative. If it's not going to work. Okay? Just remember that. The next one's an interesting example. Example F, it says a minus 2b squared minus 2ab, 2a plus b all squared. So this one is pretty interesting, but what's neat about this one is that it's really, it's basically done for you already. You could work this out and then do it, but there's a couple of ways you can approach it, but it's already in the form. If you look up in the example here, it's already in this form. So literally you can just take what's in the first and write it as the first bit, and then the second write it what's in the second bit. So again, that's just going to be how you focus on this. You could work it out, like you can multiply it out and all that if you wish, but literally what it's going to look like, it's going to be a minus 2b, right? Plus 2a plus b, right? For the first one, and then the second one is going to be a minus 2b. I'll do the minus because I was doing that at first. Minus bracket the 2b, right? And then the a minus 2b plus bracket 2a plus b. So this minus this is 1, and then this plus this is 1, right? There's a couple ways you can approach that question. Then you can simplify if you wish. And you get, this would be A, this would be A minus 2B minus 2A minus B. And then your second factor is going to be 3A minus B, right? Which would equal, and simplify this so we get minus A minus 3B. So it would be negative A minus 3B. And there's your two factors, like that, simplified. Again, you could multiply it out and do it, but an n factor, I guess, but that's what it's going to look like. Just an interesting one in this case. So we see in F, another way you could approach this, you could multiply these out and then use the factor by decomposition. It would work, but noticing that it's already something squared minus something squared, you can do it that way. So either way, it's fine. So if x squared minus bx is equal to a, then a minus b is equal to. So basically what I talked about here. So that's where these come. Just they have a 2b there, right? So I did that as one whole group, right? So it's the same idea. So just think of this as A, think of this as B, so it'll work, right? Let's look at specialty polynomials. Actually, we'll stop there. In the next video, we'll look at specialty products, the difference of squares, and expand. It might also be asked to multiply. So it could be multiply, you could say expand, whatever the case would be. So we'll look at example 4 in the next video. Okay? Thanks, everybody, and we'll talk again soon.